Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about time dilation, this really strange effect of general relativity. So the theory of general relativity made by Albert Einstein, quite smart dude, figured out that space and time are essentially really intertwined, connected with each other. So the way that space is curved affects deeply our perception of time. And one way this can happen is that when we have some source of gravity, the stronger the field of gravity, the more slower time would be experienced for something in that gravitational field. For example, we need to take this into account every day in our everyday lives. By our communication satellites, they have to take into account the theory of general relativity that time actually moves slower closer to the Earth and time goes faster for the satellites because the satellites are a bit further away from the Earth's gravitational field, so they experience time a little bit faster. And the stronger the gravity would be, the more extreme this effect would get. For example, if you get to something really massive like black holes, the closer you get to a black hole, the slower time would go to you, to the point where you're almost crossing the black hole event horizon, and from someone else looking far away, they would see the time for you would stand still. Another way how interesting effects of time could happen is when we're moving really fast. So this is the famous twin paradox. You have one of the twins who stays on Earth, and you have another twin that goes on a spaceship and travels close to the speed of light for, let's say, a few years and comes back. And now, because of the strangeness of time and speed and its strange effects, one twin staying on Earth, for them, depending on how close to the speed of light they were traveling, for them it could be thousands of years past, millions of years past. But for the twin traveling near the speed of light, for them 1 year has passed. This is what happens in the strangeness of general relativity. The speed of light, there is nothing special about the speed of light. The speed of light, 300,000 kilometers per second, is essentially the speed of causality, the speed at which anything could influence anything else in the universe. So the closer you get to the speed of light, the slower time would go to you. From your perspective, however, time would be absolutely normal, but from someone else looking from somewhere else, it would seem as you would move in slow motion, or the time for you would go in slow motion. An interesting example of this would be photons of light. In the center of our sun, there are photons born every second, and they actually take tens and hundreds of thousands of years to get from the core of the sun to the actual surface. And once they get there and they enter your eyes so you can see them, for this light particle, it took an instant. From the moment it was born to the moment it came to your eye, it's an instant. Same way as a particle from another galaxy somewhere hundreds of thousands of light years away took all this time it was born, traveled all this way into your eye, and for this particle of light, for you it took hundreds of thousands of years, but for that particle of light it was instantaneous. The moment it was born, the moment it was in your eye, same moment, instantaneous, no time for the particle of light. And also a really strange property is that if you were to somehow travel faster than light, then in effect you would go backwards in time. It's really interesting to think the closer you get to the speed of light, the slower you go. And once you reach the speed of light, you feel no time. And once you're faster than the speed of light, which is not possible, I'll tell you right now why. But if you get faster than the speed of light, time would go backwards. So it's interesting. You slow, you stand still, and then you go backwards in time, depending on how close to the speed of light you go. Really fascinating. Now, the reason why we can't go the speed of light is that speed is really closely related to inertia or mass. The closer you get to the speed of light, the more mass you have. So if you're going somewhere 99% of speed of light, you are also incredibly heavier because of the speed that you're going gives you more energy, and this energy is in the form of mass. And now think about it. The more mass you have, the more energy you need to keep going. So essentially, the kind of energy needed to keep going reaches kind of infinity. So if you're like 99.99999% of the speed of light, you already need infinite amount of energy to keep going because your mass is just almost so heavy that you would just need so much energy and acceleration to keep going. Because the more faster you go, the more energy you have, the more mass you have, and the more mass you have, the more energy you keep needing just to keep speeding up and making yourself even more massive. So that's the kind of roadblock from actually getting for anything to go to the speed of light. Now, if you don't have a mass, then you have to go to the speed of light. Exactly like particles of light, exactly like electromagnetic waves, which particles of light are a part of. Gamma rays, X-rays, infrared, radio waves, all of this is the same thing, electromagnetic waves, light. And this has no mass. And if you have no mass, then you immediately go the speed of light. From the moment it's born, whatever that has no mass, from the moment it ends some way, it's an instant, and if it has no mass, anything that has mass, it acts like a normal object, but as soon as you have no mass, you go the speed of light. So these are just some interesting properties of time dilation, how either by the force of gravity, if there's some really massive source of gravity, you're standing there, for you, time would go normally, but for someone else looking far away, your time would be going much slower. And also, the closer we get to the speed of light, time for us would go normally, but for someone else looking farther away, lots and lots of time would pass. So these are just these really interesting effects of time dilation. Hope you got some interesting ideas from it, and if you have any ideas, please leave a comment below. So thank you so much for watching, and take care.